Okay, question number 8 now. 10% of the screws produced by a machine are defective. Means how many number of screws are produced? 10% will be defective. Suppose if 200 screws are produced, then 20 will be defective and 180 will be non-defective. And the question is, sample is taken of 12 screws. What is the probability that at most means maximum 2 are defective? What do you mean by at most 2? Either no screw is defective, or one screw is defective, or two screws are defective. That all three possibilities at most 2. So even if it is 0 screws defective, that is one case. Similarly for 1 and 2, you understood. Now getting it's the question asking about defective. So getting a defective screw is our success actually. We are not purchasing a defective screw. We are calculating the probability. So probability is to be calculated for defective. So getting defective becomes success. Very nice. So how many successes we want?
2.
At most 2. At most 2 means 0 successes,
One
or 1 success, or 2 successes. I hope you understood this point. Now here P is equal to 10 by 100. That is the probability of getting a defective screw. So that is 1 by 10. That is nothing but 0.1. So what will be the value of Q? You know.
1 minus
That is
P.
1 minus P. It is which distribution actually? Binomial. Getting defective is one option. Getting non-defective is one option. There are only 2 events. That is why we are using binomial distribution. Every trial will have only 2 options. Either getting success or getting failure. That is the point. So we have calculated P value and Q value. So how many screws are taken? 12 screws are taken. So we need the probability that X is, this is the random variable. That random variable is nothing but number of successes. So number of successes should be 2 or less. Maximum 2 successes, right? So 2 screws defective like that. Now P of X equal to 0 plus P of X equal to 1 plus P of X equal to 2. What is the probability that there will be no defective screw? No, right? So 0 defective screws. So what is that option now? What is the probability now? 12 is 0, NCR, P power R, Q power N minus R. So 12C is 0, this particular suffix will be used as the power. And remaining power is to match this particular 12. So it is 0, that becomes 12. If it is 1, that same 1 will appear here. And then 12 minus 1, that is 11. And when you have 12C2, then this, what is that I written? 12C12.
Yes, sir.
12C2. 12C2 by mistake, okay? It is a print mistake, let us say. 12C2.
Yes, sir.
This 2 has come here and this is 10, 2 plus 10. So please take care that it is how much?
12C2.
12C2. Whitener was not available at the time of writing this one. So this kind of some print mistakes we can expect also in the later papers, right? So how many are over now? 8 problems are over. Now next we are coming to 9th one, that is find the mean of binomial distribution. For binomial distribution, we have P of X equal to R given by P of R, that is nothing but NCR, P power R, Q power N minus R. What is the random variable here, discrete or continuous binomial? I said binomial and discrete. Binomial and Poisson are the 2 distributions for discrete random variables in this unit. Okay,
yes, sir.
it is which unit going on? Do you
Second unit.
We are in second unit. That is limited to only binomial and Poisson. In the third unit, we will be dealing with
Normal distribution
and
uniform
distributions. So right now, for this binomial distribution, you need to remember the expression for calculating the probability. That is NCR, P power R, Q power N minus R. At least 2 times I said till now, this one. That should go to your memory. If you don't remember this, you can't do anything. And do you remember, mean is also called expectation.
Expectation of X.
So we need to calculate expectation of X. So mean of x, that is average of x, that is expectation of x, that is nothing but
E of x.
e of x. We are not going up to e of x square, only we are limited up to e of
E of
x.
x.
So what is that e of x? Do you remember the previous slide? We have done x into p. X into p. That is nothing but r into p of r. Just I have given the symbol as r. Instead of that, you can write x here, p of x here, and x runs from 0 to n. Shall I change it or let it be r? Let it be. Very good. So summation of this one is now this summation from 0 to n. This summation same. That r, this r, I have written this r, right?
Yes, sir.
What is that next? P of r. What is the property function? NCR, P power Q power n. Very good. Now this is as it is. And r I have written as it is.
Yes.
This NCR formula is n factorial by n minus r factorial into
R
r factorial. Into this one as it is. I did not change anything. Just I have replaced the value of NCR here.
Yes, sir.
Good. Next. Yes, this much is enough, right? What was the previous one? That I replaced with this one, I said no?
Yes,
This
sir.
is NCR, this as it is, R as it is. Now, if you start with R value 0, what happens? Actually, this summation starts from 0 to n. So, when R is 0,
The total value
this R is 0, this R becomes a 0, no?
Full zeros.
So this complete expression becomes a
Zero.
0. So we will start the summation from 1 onwards.
Yes, sir.
And then this R is there as it is. What is that R? R should be there here.
Yes, sir.
I think I missed it, right?
Yes,
so
sir.
what should be there here?
1.
R value 1 onwards, right?
Yes, sir.
Now where that R has gone? Anybody? Where that R has gone?
Saying that
Sir, R from 1
R into something we have.
R is 1 to n.
Yes, sir.
Then
R factorial. R factorial becomes R into R minus 1.
so good, so good. Now you are able to catch the point. I have taken one jump here. That is, this R I am writing as R into R minus 1 factorial. Right? So R and this R gets cancelled. From where this R minus 1 has come? Very simple now. This R factorial has become.
Yes, sir.
Are you able to understand that this R is finally written as R factorial is R into R minus 1. That is in the denominator. So this R in the denominator cancels here. So we will be left over with R minus 1 factorial. That is I have written here. Clear about the point. What about n minus r? This n minus r is n minus r factorial. Everything is same. That r got cancelled. Now what I am doing here is this particular, where is that one? This particular n minus r factorial. See very carefully. This n minus r I am writing as n minus 1 minus r minus 1. This is n minus 1 minus r minus 1. What is left over? This minus 1 and plus 1 gets
Cancelled.
cancelled, and then n minus r factorial is this replacement. That r minus 1 factorial is as it is. Now, okay, this n is getting continued. Are you able to understand?
Yes, sir.
This n is getting continued.
Continued.
From where this n has come? Again
Sir,
the
we
same
took a
idea.
common of n.
This is n factorial in the numerator. That becomes n into n
minus
minus 1
one.
factorial. That n is coming out. Not getting cancelled. It is coming out. Very nice. Good. So this is very nicely written in the same idea here as we have done. So n minus r can be written as n
N
minus
minus
1
1
minus r.
minus 1.
So this I have copied here.
Yes,
N
sir.
minus r. P power r minus 1 is as it is. But what has taken place?
P to the power of
P to the power of r. That P to the power of r can be written as
P to the power
P into
P to
P
the
power
power
r
of
minus 1. That P has come out here.
Yes, sir.
So left over with P to the power of
R minus
r
1.
minus 1. So are you clear up to this place?
Yes, sir.
Very nice, good. Now you see, this is like n factorial. This is like n factorial. This is like n minus r factorial. This is like r factorial. So this is nothing but q plus p whole to the power of
n minus 1.
n minus 1. In what way we are getting, do you know? First of all, p to the power of r minus 1, q to the power of n minus 1 minus r minus 1. This everything you understood, right?
Yes, sir.
Now, this summation is the expansion for q plus p
Q plus
whole
p
power
n minus
n minus
1.
r. What is the expansion of x plus y whole power n? Just x plus y whole power n.
X bar n,
X.
y bar n plus 2.
No. As per binomial theorem, x plus y whole power n. NC0.
NC0, p to the power of
X to the power of x and y I am using. X and y. X plus y whole power n. That is NC0 x to the power of n into y to the power
y
of
to the
0
power of 0.
plus NC1 x to the power of n minus 1 p to the power that y to the power of 1.
1. Yes.
That complete is this summation getting q plus p whole power n minus 1 because n minus 1 factorial you are using here, not n. It is using n minus 1 factorial. That is why it is q plus p whole to the power of
n minus 1.
n minus 1. I hope you got it. Now what is q plus p? That is 1.
1.
So 1 to the power of n minus 1 disappears and you will have just
NP.
np. n into p. This is gone. So what is the mean of capital X?
NP.
That random variable is n into p. I hope you are clear about this. Or you need again some explanation? No need. Okay, good. You know the mean, but in addition I just said that the variance is NPQ.
NPQ.
So what you have to remember now? Mean is NP.
NP.
And
Variance is NPQ.
Variance is NPQ. So nice. Okay. Now question number 10. If x satisfies that x, it is satisfying what? Binomial
Binomial
distribution.
distribution.
Mean is 6 and variance is
4.
4. Then find the probability that x is equal to
5.
5. Now given mean is 6 means NP is 6 and variance is 4 implies NPQ is equal to 4. So these two things are ready with us. Can we cancel this NP with NPQ? Yes. So
sir.
first write in the numerator NPQ.
Denominator NP. Q is equals
Huh.
to.
So we are at this step, right?
Yes, sir.
NPQ value is 4, that is variance value, and mean value is 6. So 4 by 6, that is 2 by
2
3
by 3.
using first and second equations. So Q is how much? This is the value of P. Are you getting the point?
Yes, sir.
So this gets cancelled. NQ gets
NP cancel.
very good. NP
Get cancelled.
cancelled. It is not I am calculating, it is just I am concluding this value. 2 by 3 has come, so I am writing Q is equal to this Q. Just a minute. Okay. This NPQ by NP is just Q and that simplified answer is 2 by
2 by 3.
3. When Q is 2 by 3, what is P? 1 minus Q,
minus
that is
Q.
1 minus 2 by 3, that's equal to 1 by 1. So we are ready with the value of Q and
P.
P. Now using n into 1 by 3, what is that? Where I am using this one? First equation. First equation or second equation?
First equation.
Second one. You see?
NP.
First equation is NP.
Yes, sir.
So if you substitute in
NP.
this
First
NP,
equation on this, sir.
P value is 1 by 3. So n into 1 by 3 is equal to
6.
6.
After simplification, n is equals to 8.
Yes. N into 1 by 3. So n is equal to how much? This 3 goes that side? 18. Very nice. Good. So n is decided.
Yes, sir.
Concluded n value, P value and
Q value.
We want probability for x equal to 5.
5.
That is 18C5 NCR P power R Q power n minus R. So leave this one here because the simplification takes a lot of steps. Got it?
Yes, sir.
How many successfully completed? 10 questions. Very nice. How many are there totally?
122.
No, totally
30.
20 questions to be done now. Half an hour of time is there now. Right? Find the moment generating function MGF, moment generating function about origin of
Binomial distribution.
MGF of binomial distribution about origin is just this 0 for origin and M for moment generating function. This M for moment generating function. This is the variable t. Always you remember this particular equation for moment generating function. What is the moment generating function? Always you write about origin like this only, and always you use t only. This is the notation for moment generating function about origin. That is equal to expectation of e power tx. Keep in mind, e to the power of tx. Expectation you are calculating for g of x, do you remember?
Yes.
So what you have to do for the expectation of g of x? The g of x you need to multiply with the probability. Good, very nice. So this moment generating function is sigma r is equal to 0 to n. Because it is discrete, you have to use sigma. If it is continuous, you have to use integral. So what is that expectation you are calculating for e power tx? So e to the power of tr will come, just because I am using the symbol as r. So e to the power of tr. Here this e power tx has become e power tr, and you have to multiply with p of r, that is the probability of r. So what is the next step? P of r. P of r value is substituted. NCR, P power r cube to the power of
n minus r.
I'll just pause here and I'll say one thing. If you are calculating the moment generating function about origin for Poisson distribution, then this left side is same.
Yes, sir.
This is also same. E power tr is same.
Same.
This P of r becomes P of x is equal,
Yes,
sorry, that probability value is how much? E to the power of minus lambda into lambda power k by k factorial. That k you use here.
Yes, sir.
K is equal to 0 to
N.
n, not 0 to infinity. Better. Because Poisson distribution will have infinite number of values. So it starts from 0. So that k value runs from 0 to infinity. That's summation. So are you clear about this point? Shall
Yes,
I
sir.
move forward?
Yes, sir.
Yes. Now some simplifications only. Just the simplifications. Acha, that should be there here, no? This line. So what is that? NCR
Q to the power of n minus r.
q to the power of n minus r. I am writing first that q to the power of n minus r here. And that p is for power r. You check it once. P is with r power, no? This
Yes,
p
sir.
to the power of
R.
r. And e to the power of tr is rth power for
E to the power of
e to the power of t. Can I write it as e power t whole power r?
Yes, sir.
Yes. And this is p power r. So
Yes, sir.
combining both terms, what happens?
P into
P into e to the power of t whole to the
Whole
power
to
of
the power of
r.
r.
So everyone clear about this?
Yes, sir.
Now you see. This q I have written first and p I combined with e to the power of t and this whole r. So this complete summation is nothing but
Q
the
plus
expansion of q plus p e power t whole to the power of
n.
n. So this is the moment generating function. This t is there, no? That is what we have written. That m naught of t. That t has come here. So q plus p e power t whole to the power of n. So what is moment generating function now? Q plus p e power t whole to the power of n. Now if the in bits if you get a question, that is what is moment generating function for binomial distribution, then m naught of t is equal to q plus p e power t whole to the power of n. No problems are getting asked on moment generating function, means they are not giving any problem where you have to find that and all these things. Actually it is a moment generating function. If you expand, then powers of t will come. That coefficients will give some important values. That is why this is meaningful. To calculate that kurtosis, to calculate that skewness, that will be getting used. So we are not doing anything on that. Now it is fitted binomial distribution for the following data. So x is taking what values? 0, 1, 2, 3, 4, 5. Means it is like 0 success, 1 success, 2 successes. So what is n here? N is maximum taking 5, right?
So it's closed.
Stop.
Yes.